We have two types of dihalides. We have number one, geminal dihalides. We have number two, vicinal dihalides. Geminal dihalides are dihalides in which the two halide groups are attached on the same carbon. Dihalides in which the two halide groups are attached on the same carbon. This is an example. Two halide groups are attached on the same carbon. This is halide, both of them are attached on this carbon. If I replace this guy with, let's say, bromo, it becomes Br. This is an example. Vicinal dihalides. These are dihalides in which the two halo groups are attached on adjacent carbons. The two halo groups are attached on adjacent carbons. Okay, we have something like this. They are attached to adjacent carbons. Emphasis on the adjacent, like the one that's directly attached to the next one. Okay, so if I replace this guy with bromo or chloro, now CH3, C, let's say this. So this is an example of vicinal. Right, vicinal dihalides are dihalides in which the two halo groups are attached to adjacent carbons. Preparation of vicinal dihalides by reaction with halogens. Now look at this. Reaction of what? Reaction of alkanes with halogen. Now this reaction is very similar to reactions of in 132 when we said reactions of halogens with alkene. Do you remember those reactions? So we have example 1. If I have CH3 plus, we have this. So this becomes now this is like. So if you notice, they emphasized on the vicinal. They did not just say the halide, because this method cannot give us geminal. Right? This method cannot give us geminal. For me to get geminal, I have to use another method, which I said in exams, they may not really ask you to do that. Right? So we just stick to this. So if I replace this guy with real halogen, we have this. So this is 1, 2, 3. This is 1, 2, and bromo propane. Note, the stereochemistry of this reaction is anti. The stereochemistry of this reaction is anti. The stereochemistry of this reaction is anti. Now please, this anti simply means, let me edit this part. What we mean by the stereochemistry of this addition is anti means that the two halogens that is being added here are added on the opposite side. That's what it means. So this guy that was here is not supposed to be here, it's supposed to be what? opposite. So that's what we mean by and. So please take note of that. Dihaloalkanes can be used to prepare alkynes by a double dehydrohalogenation by halides. Dihaloalkanes can be used to prepare alkynes by a double dehydrohalogenation of terminal dihalides. What's the next one? It's good. I want us to pay close attention, right? I'm going to write two reactions here for us. Now, once you see this guy, this puts out the first hydrogen halide, puts out the second one. And what do we have? An alkyne. We have this plus 2 ammonia plus 2. Now, we have two of these, Na, NH2. The first one, Na, NH2. If you remove two of these, the first H will come here, it will add and form NH2, right? The second H will come here and form what? NH2. This gives rise to the 2 ammonia. The first X comes out, the second X comes out, that gives rise to what? This and this will give rise to 2, right? Now, if you notice, this alkyne here is internal alkyne. Now, why do we say it's internal alkyne? Because the 2 carbon of the triple bond is further attached to carbon, right? And this R is an alkyne group, so it is presumed that there is a carbon here. But assuming any one of these were to be hydrogen, this here would have been a terminal, right? So if a terminal alkyne is formed, this will be 3. This will no longer be 2, to be how many? Now look at this, let me show you an example. If I replace this guy here with H, so let's give us the reaction. Let's go. This is what would have formed, right? Just like we did previously, it's not so. But then this guy is a terminal alkyne because this H, this place is having H, right? We're not going to stop here. One of these bases, remember I gave us 2 here, but this guy is having, there is 3 here for a purpose. Because one of them is actually going to pull out the hydrogen. Terminal alkynes is considered as an acid particle, right? So here is going to be Na. Now why is this so? Because this alkyne that was supposed to be formed here has 1 hydrogen. So anytime, now look at this 2 carbon is not having any hydrogen. That is why this is not happening here. But once any of these carbon is having 1 hydrogen, right? This guy is not just going to form alkyne. It has to form an intermediate first. That intermediate is always sodium what? Acetylide. It's a must. Now when you now add your water, this guy now becomes that is it. The exam, this is how this question might look like in the exam. Let me show you something. They can come here and make this place to be A. And come here and make this place to be what? B and say complete the reaction below. Or what is A and what is what? B. Very simple. For the fact that you've seen 3 sodium amide here, it's giving you the vibe that this guy is going to be sodium acetylide. Right? Meaning that this was supposed to be a terminal alkyne, but an intermediate was formed first to usher us to the main product. And how do you know that? Look at the dihaloalkane. Is any of this carbon of bearing the halogen having H? Yes. So it means that these 3 sodium amide is justified, right? So the first thing will be, come here, R. This is what it's supposed to form. Is it not so? But because of this guy is 3, here it becomes how many? Na. Once you add water to this guy, this Na will be removed. And here becomes H. Do you remember Chem 6 when we did addition of Grignard reagent to our ketone? We form OMG X. When you hydrolyze, this guy becomes what? OH. I wonder how you guys forget stuff so fast. Yeah, I still remember what I did in the 1. I'm serious. I still remember what I did in year 1. I'm not joking. Carbon we have is 4 carbon. Are you aware? There is carbon here. There is carbon here. There is carbon. Now you say, why did I do this? This is not supposed to be your business. Just put it back. My only business is 1, 2, and 1 of this. Right? So this is what I'm going to do. This one will come here. 1 of this will come here. And 1 of this will come here. Finish. And you come here. This, right? This bond. This one. This one. Is it also? Now watch. We had 3 here. We have used 1 to form this bond. Remaining how many? Now remain 2 back. Please, this place, don't put it like this. This up is supposed to go like this, right? We have to do what? A, B, C, and D. Please look up. You put this guy. This guy comes here. Right? This one goes here. Okay? Now, this, 1 of this. But first, this is this is supposed to be first. Then also, this guy now come here. Have this. Now this stuff, you now project it like this. This now becomes carbon A, B, C, and O. So this is a product of that guy. Note, there's other reaction. We always give a 6-membered ring.